Hi, in this video we're going to take a closer look at our results and we're going to iterate through different simulations to quickly get some conclusions on the environmental impact of our design. We can see from the results of the previous video that we might have generated some discomfort on the site. If we look at the legend, we can see that certain corners of the site reach a speed above 5 meters per second. We can also deduce that certain areas are also reaching an uncomfortable level, as on the scale we have levels close to 1 in the proximity of our design. Considering that we might not be very familiar with the local climate nor environmental simulations, and that we ran this analysis with not necessarily consistent parameters, we might need to go deeper into the understanding of the results obtained. For that, let's go to the sun icon to open the climate dashboard. The different tabs represent different weather data collection in 1 year period. Under this tab, we can check temperature and humidity levels. From the graphs, we understand temperature can drop harshly in winter months and rises heavily in summer too. Let's pass on to the wind info, for which we are also running the simulations. On the wind rows, we can deduce Vienna is hit by wind in several directions and that those winds currents can reach high speeds. If we go down and check the wind speed chart, we can observe some blue spots that represent episodes of high wind speed, especially in winter. By moving to the left side, we can isolate those episodes to check them more in detail. We can detect a speed of 14 meters per second and that occurred with wind blowing at 280 degrees. Remembering the very low temperature in that season and the high levels of humidity, we can expect extreme levels of discomfort in this occasion. So let's go back to our project and let's run a simulation quickly with these conditions. Now let's set the values and run other two simulations of wind speed and wind comfort with the current conditions. We can see here that we persist in generating uncomfortable settings on the ground floor. Let's assume we might fix the situation by adopting the same neighbor tower strategy and we match the building's rotation. Then we run again the simulation. We can see that the results have not improved, and by orienting the building against the current, the situation might worsen the conditions. Let's try then to mitigate the building impacts by position. We can try the results at different locations. We can see in this solution we have achieved a condition of lowest impact. Now let's try instead to verify the condition in summer, when a nice breeze would benefit the sensation of comfort by lowering humidity and temperature perception. For that, let's go back to the climate dashboard. On a general overview on August day, let's see the most common direction. I would say bluish values are more frequent, therefore values between 50 and 100 degrees. Let's simulate these conditions and let's see if we achieve to generate refreshing breezes on the ground. We see here that the impact in summer at the current condition does not have major effect on the area. So let's try to rotate the building. With the rotation, we have generated a small increase in speed and therefore an impact on comfort too. With a few steps, we have figured an interesting strategy for the location of our design, keeping in mind its environmental effects.